All right, so today we are making a foldable. So the first step is to fold your paper in half. Once you have it in half, now fold it into thirds. You can see mine has a little bit of an overhang. That's okay. Go ahead and open it up. You can see you have 6 different sections. Okay. Take the right section, and we actually want to fold this into 6 little squares on the right. So I'm going to fold it into the center. And then I'm going to take my pen and I'm going to trace the 6 little blocks. Notice we only fold it into the center on one side. This side only has 3 rectangles. This has 6 squares. So trace the 6 squares. Okay, so when you open it up, you can see the 6 squares, but these are still large rectangles. Now I'm going to cut on the folds. And if you don't have scissors, that's okay. You don't need to cut them. But I'm just going to cut to the fold there. I'm going to cut 3 flaps here that open up, so I can see the 2 squares underneath. Okay, this top one is going to be 1 solution. The next one's going to be no solution. And the bottom one's going to be infinite solutions. For 1 solution, when we open it up, we're going to start with a fairly easy equation. So 2x minus 1 equals x plus 2. Now, right off the bat, we can tell that this has 1 solution. And we know it has 1 solution because the coefficients on x are different. So difference. Coefficients on x. And let's go ahead and show that this has 1 solution. Now, once you have the equation in simplest form, no fractions, no decimals, no distribution needed, now we need to put all of our variables on one side. So I'm going to subtract x from both sides. On this side, 2x minus x is just going to leave me with 1x. Minus 1 equals, and x minus x is 0, so I'm just left with a positive 2 on this side. Now to isolate x, I need to add 1 to both sides of my equation. So remember, whatever I do to one side, I must do to the other. And on my left side, x minus 1 plus 1 is going to leave me with just x. And on this side, we get 3. So when an equation that has variables on both sides have different coefficients on the x variable, now that could be x or y or t or whatever the variable is, only one value for x will satisfy the equation. Now, don't worry about this box. We'll get this box on Monday, and that's why we're putting this online so that students that weren't ready to take and make this foldable can make it over the weekend and have it ready for Monday. So let's take a look at no solution. So an equation that has no solution is one like this. And I'm actually going to keep it very similar to this equation. Look, the left side is going to be exactly the same. And I'm only going to change one thing. But that one change from this equation to this equation took it from one solution to no solutions. So take a look and see what change I made. It's right here. In the first example, I have 1 as my coefficient on x on the right-hand side. And in this example, I changed that to 2. So now if you can see, on my x's, they both have the same coefficient. So they have the same coefficient here, but these numbers are still different. These are the constants. So they do have different constants. So let's go ahead and show why this has 0 solutions. So remember, I want to move my x values all to the same side. So to do that, I need to subtract 2x from this side. And whatever I do to one side, I have to do to the other side. So I'm going to subtract 2x from this side of the equation as well. And on this side of the equation, I'm going to get -1. And on the right-hand side, I'm going to get a +2. Well, -1 does not equal 2. So I'm going to slash out my equal sign there. And over here, I'm going to write that no value for x will satisfy the equation. Now let's take a look at infinite solutions. Now when you get an equation with infinite solutions, they don't just have, both sides of the equation look exactly the same right away. Nope. Typically, they'll have them look different at first, and only after simplifying this equation will you see that both sides of the equation are exactly the same. So here, I need to distribute this 2 to both terms inside the parentheses. So I'll get 2x plus 2 equals 2x plus 2. So in this case, the coefficients are exactly the same, and the constants are exactly the same. So same coefficients, but unlike with 0 solutions, instead of different constants, when we have infinitely many solutions, we also have the same constants. So just like we did up here, let's go ahead and solve this so you can see why it's different. So we need to move all of the variables to the same side of the equation. So to do that, I'm going to subtract 2x from this side to get it off of that side. But whatever I do to one side, I must do to the other side of the equation too. So I'm going to subtract 2x over here as well. 2x minus 2x is 0, so I'm left with just a +2. And 2x minus 2x is 0, so I'm just left with a +2 over here. And 2 equals 2 every time, all the time. So it doesn't matter what we put in for x, this equation is going to be correct. So every value 4x will satisfy the equation.